So one-step inequalities. So graphing inequality solutions, you're going to write the inequality so that the variable is on the left side, okay? We determine the type of circle to use. So if it is greater than or less than, it's going to be an open circle like this, okay? If it is greater than or equal to or less than or equal to, so it has the equal to sign, it's going to be a closed circle because it includes that value, like just a dot that's closed, okay? Then we draw the arrow showing the graph, so because it includes everything that is in that direction. So if it's greater than or equal to, it's going to go to the right. So if you look at your symbol here, our greater than and equal to symbols, you see this little pointy part, the vertex? The direction it's pointing is the direction that you're going to draw your arrow. So that's really nice. And then less than or equal to is going to go to the left. Okay? Just the same thing, the pointy piece of my, or the vertex of my inequality sign, the direction it's actually pointing is the direction your arrow is going to go. So let's graph these. So I have my variable on the left, my symbol, and then my number. So I'm going to draw a number line. 0 does not necessarily have to be in the middle for these number lines, but if it works well that way, then you use it. Is this going to be an open or a closed circle? Open. And it is greater than, so it's going to be going to the right. Okay? Yeah. Again, drawing our number line, because this is 0. 0 is nice to have in the middle. Is it open or closed? Closed, because that's the equal to, and then it's going to be going to the left. This includes every single value that is less than 0. Okay? Or equal to 0. Again, drawing my graph. I'm going to start 0 over here. 1, 2, 3. Open or closed? Closed. And it's greater than or equal to, so it's going to the right. Right, so my symbol or my variable isn't on my left side here, so I need to rewrite this. So, however, I still need the less than part or to be pointing towards my x, okay, because you can't change the sign. So I need it still to be x is less than, because this is x is less than 3, so x is less than 3. Okay, because you need to have your x on the left for your variable. Okay, and then 0, 1, 2, 3. Open or closed? Open. And then it's going to be pointing to the left. So that's all that it takes to graph an inequality. And all inequalities usually get graphed. Usually. So the only time that you probably won't graph an inequality is if the word problem. Or if it's specifically telling you not to graph or to graph. Okay. Solving inequalities. So you solve inequalities using the same steps as equations. So today we're not worried about this, but we will be doing this tomorrow. So you have to think about if it has parentheses, you're going to distribute. If it has fractions, you're going to eliminate your fractions. And then you're going to combine like terms. You're going to isolate the variable by adding or subtracting it to moving it to one side. You're going to move the constant to the other side. And you're going to divide to get the variable, multiply or divide to get the variable by itself. The same steps that we've been doing for solving equations, we're doing them for inequalities. The only thing that's different here though is if you multiply or divide by a negative number to solve the inequality, it reverses the inequality sign of the problem. So for example, you don't need to write this down, but we're going to be doing this later. But let's say I have like negative 3x is greater than or equal to 12. I would have to, in order to solve this, I'd have to divide by negative 3. So I have to change my sign to less than or equal to. Okay, you reverse the symbol. Okay, and so my x would be less than or equal to -4. Does that make sense? Okay, that's what it means by reversing the sign. You flip it. Okay, and then your answer will have 3 parts. We need to have our variable on the left, our inequality sign in the middle, and then the number. Okay, and then we graph the solution on a number line, just like we just did. So here, in order to solve this problem, I'm going to add 3 to both sides. So did I multiply or divide by a negative number? No, so I'm going to keep my sign the same. So -5 plus 3 is going to be? -2. So then I'm just going to take my graph. And I'm going to have open or closed. Open. And then it's going to be going to the left. Okay, I would have to subtract 4 from both sides. Did I divide by a negative number? No, so I'm going to keep my sign the same. And 1 minus 4 is? -3. Open or closed? Closed and to the left. Okay, in order to solve this problem, to get n by itself, I'm going to add 6 to both sides. Did I multiply or divide by a negative number? No, so I'm going to keep my sign the same. And -2 plus 6 is +4. However, it's not written the way that we like it, where our variables on the left and our numbers on the right. So I need to rewrite it, but we need to keep the sign where that the greater than part is touching my n. So that means it's going to be n is greater than 4, okay? And is this going to be open or closed? Open. And it's greater than, so it's going to the right. Okay, here I'm going to have to add 1 to both sides. So did I multiply or divide by a negative number? No. You see how I am asking myself that, or asking you guys that? You should be asking yourself that when you're solving the problem. And what I like to do, I like to write the symbol before solving, okay, before adding, or subtracting, or multiplying, or dividing, so that you know that that's what your symbol is going to be, okay? So I have x is greater than or equal to -2. So is this going to be open or closed? Closed and to the right. So that's adding or subtracting. The next side is going to be multiplying and dividing. Alright, so in order to solve this problem, I'm going to have to divide by 2. Did I multiply or divide by a negative number?
Yes.
Did I multiply? What is 2 negative? No. So did I? No. So I'm going to keep my sign the same. -6 divided by 2 is a negative number, but that doesn't mean I multiplied or divided by a negative number. Okay? So I'm just going to graph my inequality. So open or closed? Open. And to the right. Alright, so now here I'm going to be dividing by -3. So I divided by a negative number, so I need to reverse my sign. So instead of greater than or equal to, it needs to be less than or equal to. You see how I do that first before I even solve my problem? Because then I know that I'm not going to make a mistake. Okay? So -18 divided by -3 is +6. 2 negatives makes it positive. So then I'm going to do my number line. Open or close? Close, and it's less than. All right. Here I'm going to multiply by -4. solve my problem. Multiply by negative 4 because that will cancel out my 4 and my negative. They move x. So I multiply by a negative number, so what do I need to do? Flip the sign or reverse the sign. So I'm going to make this, instead of less than or equal to, it's going to become greater than or equal to. And 4 times negative 4 is negative 16. And I'm not expecting you to go from 0 to negative 16. So I'm just going to start over here with negative 14, negative 15, negative 16, negative 17. And is it open or closed? Closed. And it's pointing to the right. Okay, here I'm going to be multiplying by 3 to solve my problem. Did I multiply or divide by a negative number?
No.
No? So it's still going to be greater than or equal to. And negative 2 times 3 is negative 6. Open or close? Close, and it's greater than, so it's pointing to the right. So one step inequalities has literally one step. You do one thing, either add, subtract, multiply, or divide. The main thing that is different between solving an equation is that if you multiply or divide by a negative number, you have to reverse your sign, okay? On the next slides, we're going to be doing word problems. A lot of times with these word problems, you just have to either just write the inequality or you might have to solve some of the inequality. However, you don't have to graph these ones, okay? So it says the world record for the largest blue marlin ever caught was 1,376 pounds. Wow, that's a big fish. Write an inequality describing the weight of all other blue marlins that have ever been caught. So all other means that it does not include that one, right? So it's going to, my x, what?
Would it be less than?
It's less than 1,376 because my variable, we could have made m or b or whatever, has to be less than that 1,376. It can't be less than or equal to because it doesn't include that marlin. If it said all marlins ever caught, then it would include it and we'd have to put the equal to sign. But it didn't say that. It just said all other. And that means it didn't include the largest. That's a big fish. That's like a car.
That's massive.
I don't want to see who caught that thing. Crazy. All right, so let's look at the next one. So you need at least, so I need more than $125, right? So I can just even do that, more than $125 to go on vacation with your friend. Right now, I have $65. So I have $65. Write and solve an inequality to show how much more money you need. So I need to add my variable. So my x plus my 65 has to be greater than or equal to, because we can have at least. I can have if I have $125, I can go on this trip. But I can also have more than that and have a little extra spending money. So I need to solve, it says write and solve. So I also need to solve. So I'm going to subtract 65 from both sides. So did I multiply or divide by a negative number?
No.
No. So I'm going to keep my sign the same. So x has to be greater than or equal to 60. And this is a type of problem that's a real world problem. So I need at least $60. So I need at least $60 to go on this trip. If I have more than $60, that would be beneficial. But I need at least.